Hello, welcome and good evening, and we're back with the fourth episode of Let's Code MS-DOS. In the last episodes we set up our coding environment, we learned how to handle key presses, and we learned how to initialize the VGA card, set a palette, and draw some nice background. So far this isn't much of a game, so in this episode we want to draw something on the screen. It will be very simple, but we have a lot of ground to cover still, so I think that will be challenging enough. We also will animate kind of what we are drawing on the screen. And again, this will be very simple, but you will learn all the basic concepts to later build even more complex games and stuff, right? In the background I already have the help PC reference library handy, because we will need to use one or two additional hardware registers and stuff. Yeah, first of all, we want to make this thing more playable. So, first of all, we will have 2 players in this game. I'm not yet quite certain if we will make it so that this will be against the computer. Maybe it's simply enough that we can do that. Or if we will have a second player who's also playing on the keyboard or something. We will see as we go along. It really doesn't matter that much. Right, so in the main function we will need to carry on the state of the players, and we'll call them player P1 and P2. We will need to define what a player is later on, but let's just start by saying what we want to do with them. So player has some kind of color, and for simplicity's sake I will take color 255 because that's the last in the VGA palette. The first couple hundred colors we already used on the background, so I'll just take the last color here. Every player will also have some geometry associated with it, some height, and let's say it has 30 pixels in height and also some width, let's say 5 pixels, so will be tall but very thin. And there will be a player position, an x coordinate, and we'll set it to something small, and a y coordinate, which is somewhere in the middle of the screen. So we take the screen height divided by 2, and we subtract the player height divided by 2, because then we will have it exactly centered on the screen. And all the players will have scores, which we will have to track later, so we won't need it in this episode, but yeah, that's fine. Also, when we draw something on the screen, it will destroy whatever was under there, so there are different solutions to solve that. The most simple one that we will use here is to just store whatever was under there and put it back when the player moves, so we don't have to redraw it. This will work in this kind of game. In other games it will be more difficult and you have to use different algorithms, but for now this will do. We need to allocate that, we know how to do that. And how many bytes will we need? Well, basically the size of the player, which looks something like this. And then so that it's filled with garbage, right? That will be totally random. And for clarity's sake, we will use memset to set all the allocated bytes to a predefined value, which will be 0, color 0. I think it doesn't matter because we won't be using this first backup, but just to be on the safe side, so we don't get any garbage on the screen, right? And memset is pretty simple. You give it the pointer to the memory area that we want to set, and that's basically just whatever malloc just returned. We say which character do we want to use. We want to use the character 0, so we want to write zeros there. and then the number of bytes, which is again the size of the memory area that we allocated. Same goes for the second player. We will simply copy this whole stuff. And I don't know my word star commands that well, so I will simply manually replace P1 with P2. Make sure to get everything. Here it doesn't actually matter because the players are of same size and stuff. So that's all good. But the player position should be something different. We want to place this on the right side, so we take the screen width minus P2 with minus 5, so it's the same thing from the border. Okay, that's good. This will not compile, not at all, because we haven't defined player. And how to do that? How to do that indeed? Well, we are in C, we can't use objects, but we have structs. So I will define an alias for a structure. A structure is basically similar to a class in C or in Java, but it can't take on any functions. It will simply be a collection of variables. So type of struct player. This is now the new type player. And yeah, what does it have? It has a color. And that's a byte, because VJ colors are bytes. It has a position, and we take an int here. This will be 16-bit ints. This will be enough to address the whole screen. It also has a width and a height. We might limit this to bytes, but it doesn't matter much here. We have so few variables that it will not be a problem. We have a score, and we have some kind of backup buffer, and that's a pointer to bytes from the screen. And that's already it. This should compile with 2 warnings. Code has no effect. That's for sure. We need to initialize this. But we won't see anything, right? We have defined this, and nothing will be drawn actually. So maybe we should concern ourselves with the drawing, probably. So what do we have here? We have the run loop, basically. As long as we don't press escape, we are looking around to see if there's a keyboard hit. But what's the steps? The steps will be every draw loop that we make, we want to restore whatever was beneath player sprites. We'll do that here. So we have something like restore player, or whatever we want to call that. What did I call this in the preparation here? Just so that you know, I have some notes. I'm going along a little bit ad-libbing this, but I have tested this before. Restore player P1. Yeah. And the same for player 2, so that the screen is in a sane state, right? Then we handle all the keyboard stuff. I won't change that right now. And after the keyboard handling is done, we will do something like, because maybe there were other draw routines and there was state updated, and we will store whatever is now under the player. So we'll call store player P1 and store player P2. And also then we have to draw whatever the new stuff is that the player state is in. Right? This breaks everything down into rather small functions that we can actually understand and reason about. Yeah, I think this is pretty okay. We can try to handle this. Let's go on to define whatever these functions are. So we have a store player function which takes a struct. Oh no, we don't even need to write that in C. We want a pointer to a player, and we need to have something to restore whatever the player was doing. No, whatever was below the player in the frame buffer, and we need to be able to draw the player with whatever features we want. And this is something that you can play around with later, where you can make the player sprites more fancy and do more stuff. But this should now again build, but not do anything, because it will say, yeah, here's unused parameters, we don't do anything with these empty functions. But that will compile and run and do nothing. Before we do that, we can actually do the keyboard handling. So we don't want to deal with the special keys, so I kick out all the stuff here, ignore the other keys, and here as well. We want to do something if we hit the up key, because then we want to move our player up. So basically player 1 dot y, and we will subtract, I don't know, 2 from the coordinate. And then we need to check if we run out of the screen. If y is less than 0, then we will do, say, y equals 0, so we clip that we can't run from the top of the screen. And we can do the same for the down key. For the down key, we add to the current player coordinate, and if this is now greater than the screen height, stop right here, y plus player 1. Oh, and look at that, this will be a nice syntax error. So if the player y coordinate plus the player height is bigger than the screen height, then we say, let's do this to screen height minus player 1 height. So clipping to the lower end, right? Now we already have some game logic. We can move the player up and down. That's pretty neat, huh? Okay. So first things first, store player. What does store player do? We need to do some block transfers. This is called blitting in the game programming, retro game programming language. Some computers like the Amiga and stuff, they have separate chips for doing the blitting. The PC doesn't, so we will do some memory copies. But we will make a utility function for that. We will call this blit to mem, because we will block transfer stuff from the VGA frame buffer to our own memory that we allocated, the backup buffer. And this will go to the destination player backup. And the coordinates will be wherever the player currently is. And the size will be the player width and the player height. I could have put this all into this function right here, but I think the blit functions will come in handy later as well if we want to do other stuff. So you can actually use them. And these parameters here are very specific to the player object itself. So it's better to pull this apart. So what does the blit to memory function look like? Because now we will do more of the nice pointer stuff. The function here will, what will it get? It will get a pointer to the destination, and we don't know what kind of pointer this will be. I mentioned this once, we are here in the small memory model. In the small memory model we only have 64K of code and data, and all the pointers are near pointers, so only the offset. But malloc might return far pointers or whatever the programmer here used. So we are demanding a far pointer here to be on the safe side, and also for the opposite direction when we do the blit to VGA in a minute, that will definitely need a far pointer because the VGA memory is in a completely different segment, as you learned in the previous episodes. And if you haven't seen that yet, check it out so that you know what we're doing here. This is MS-DOS, totally MS-DOS specific, as I said. You won't have to deal with such stuff under Linux or modern Windows systems or macOS. Okay, so yeah, we take that. We take the X and Y coordinates, we take the width and height, and I'm gonna use very short variable names here because the formulas will be not much clearer if I use longer names. We need to iterate over something because we need to go scanline by scanline, and we need to calculate the source pointer, and we need to calculate a destination pointer. What does the source pointer look like? We are copying from the VGA memory, and we defined already a pointer to VGA called VGA. And the offset will be, of course, the X coordinate and the Y coordinate for the start at least. We need to multiply this by screen width, so we have the correct offset into the VGA memory to skip Y scan lines basically. The destination pointer is simple, just whatever the user supplied us. So now we can actually iterate, and we go from scanline Y to Y plus height of the buffer, and we just code up. Very simple. So we go over all scanlines from Y to Y plus height. And yeah, now we can use a function, and we need a function that actually takes far pointers, otherwise it will not work. All the stuff that we have here, like memcopy, which is standard for C and Linux and everything, it will take just a void pointer, which is in the small memory model a near pointer. So this will not work. However, there's one function called moveData. It will take actually segment and offsets. So we can take our far pointer here. It will be something like this. moveData. How do we indent this? Something like this. So moveData, it needs to take somehow the segment of the source pointer, somehow the offset of the source pointer, and the same for the destination pointer, and then the number of bytes, and every scanline is W bytes with bytes. But how do we get the segment and the offset? Well, you're in luck. Let's take another look at the memory header. And it doesn't say that here, right? I'm wondering which of these things defines that. Maybe the DOS? Yes, the DOS header. The DOS header does this. There's these two things. FP stands for far pointer. This gives us the offset and the segment of the far pointer. It's basically just ending and bit shifting the pointer that you have on hand. So you can do it actually yourself, but it's easier to do if you have this macro basically. So to get the segment, we just write fp segment of source, and to get the offset we write fp off source. Same goes for these two, fp segment of destination, and same here. This should already compile. This will copy, and it doesn't because I had a typo. Hands up who saw that already. You're probably seeing much more than I'm doing here. And move date is also wrong, of course. Move data. So this is better. Now we only have two warnings for the other two unimplemented functions. Okay, this is one of those two functions. The other one will be to restore the player. So here we will have to blit from memory to the VGA. And the blit to VGA will also take the backup pointer as a source this time, and the other stuff as well. So there's no change. It's only the direction changes, and the whole function will look, of course, slightly different. And what does it look like? Well, we can copy the signature as well. And it will be called blit to VGA. And this time the file pointer is the source. We will also need to iterate over the scan lines. And we will actually I can really copy this whole stuff. There are people that say don't copy and paste, just rewrite, because you will make errors by forgetting to change stuff. But we won't. We are better than that, aren't we? So, this looks good. So the source pointer is whatever the user supplied, the destination pointer is the VGA pointer as defined before. Then we iterate over all the things here, and Siri is thinking that I want to talk to her, which is not true. Okay, so this is okay, and I think I already made a mistake down here. Yes, but we can fix it. We can fix it. So we do the move data, and as you can see, source and destination pointer neither here nor there will change at all. So after doing the move data, we need to increment the source pointer. And how much? We will, for the source pointer, this is the backup, it's W wide, so we will add W to skip to the next scan line, and the destination pointer has screen width, so we add that to get to the next scan line. And this is the same here, except with the other thing. The source pointer will be the VGA, so we'll add screen width to get to the next scan line. And the destination pointer will add the width of whatever the user supplied us. This looks much better. Okay, this should compile. It does, and we only have one unimplemented function. Draw player. Yes. Draw player, draw player. What does draw player look like? In this game, it will be simple. We will draw just a rectangle. And this will draw directly to the VGA framebuffer. So we say draw a rectangle from coordinates x and y with width w, no, width it's called, right? Yeah. And height as the height. Done that, but we need to implement that as well. We won't get around that. Well, drawing a rectangle is easy. You can later just like load graphics, define your own graphics or whatever, do sprites in all kinds of ways. We won't be talking about transparency yet, because that's a whole another can of worms, but that will probably be maybe in season 2 if there's enough people wanting to watch this. But for now we will just draw colorful rectangles. Oh, and we probably should say that we want it in this color here, right? So these are basically just all integers, int x, int y, int width, int height, and some color. Sounds good. And this will be very simple. We probably could do some more efficient drawing routine, doing 16-bit writes and stuff, but we won't. Not right now. This is all too complex already. So we will just again iterate over all the scan lines from y to y plus height of the player and increment the j, and there will be an inner loop to draw the individual pixels for every line. So this will go from x and to x plus the width that was applied. We'll increment the I, and well, now we need again our destination pointer. And I write this on one line so it's not such a weird expression. It will be the VGA buffer plus the y coordinate, which the x coordinate, which is I, plus the y coordinate, which is j, times, as usual, the screen width to jump to the correct scan line. And that's it, basically. So we say take this address and use it to store this byte. This should already work. It compiles without any warnings. I have to compile again. And there's something here. You will see weird stuff. Oh, key pressed, yeah. Let's kick that out. That's ugly. We don't need that. Let's take a look again. Yeah. Okay, this is not not working as well as expected. There's some blinking stuff and the store restore doesn't work. So we need to find out why that is. We do have the store player, restore player, and draw player, and we are calling restore player, and yeah, we probably should have stored. First of all, we should have stored whatever was in that thing in the beginning, because we didn't do that. So we have this color here that we set. So we should definitely do that after drawing the background, and which means we can actually skip this. We don't need that. So we just say store player P1 and do the same for P2, but I think there will be another bug. This didn't look quite right to me. Yeah, this still does suck. So we need to take another look. And you guys probably already saw that. Me typing away and copying away, the destination pointer was completely bonkers. So we overwrote some memory inside the machine. And as you can see, there's no general protection force or anything. We were just lucky that it ran at all and didn't do weird stuff. Yeah, look at this. Now it's flickering, but it's moving. And I think it's moving too slow. I want this faster, but I can move it up and down. But the flickering is annoying, right? But we can hit the top and it won't crash or move out, and we can go to the bottom, and that works as well. So we can move our player sprite up and down. So I want to change two things. First of all, I think this is not wide enough. Let's make it 10 for both players so we can see it properly. The color is also ugly. We will change that in a minute. We want to do it faster, so we move by 3, no, by 4. 4 is better. And this should be already better. But now the flickering is even worse, right? So yeah, it moves faster, looks good. The flickering is terrible. So the flicker happens because we are basically clearing whatever the player was at and then redrawing it. And the screen refresh is so fast that we will see parts of that at least. So back in the days we were using cathode ray tubes, so the big bulky screens that were scanning the screen with an electron beam. And when it was at the bottom of the screen, it would retrace and move the electron beam back up. And during that time, no picture would be displayed, and in this gap you could actually do all the redraws. And that's what we're going to do. So we need to take a look at the helpc library, and we need to get here, I think the hardware data specifications maybe, and then ports. There will be VGA ports. There will be something called there will be something from VGA, and I think it will be this here. So basically we need to find the register, and I think it's not very accurately described here. So this is the status register 6845. We should look at the 6845 Motorola CRT controller. Okay. Yeah, that sounds about right. But yeah, here we are. That's what I was looking for. Port 3DA. Sorry, I didn't find that right away. Port 3DA. It has a byte here. A bit. This is the status byte. If you read this port and take a look at the third bit, so that's decimal or hexadecimal value 8. There's a 1 if we are in the vertical retrace. RAM says OK for next 1.25 milliseconds. So we need to be working inside of this time whenever this bit flips on. And we can do that. We are fast. We can make it. So we will define a new I/O port here. We will call it input status of the 6845 Motorola controller, and we'll define the vertical retrace bit as 0x08, and we'll write a little function that checks for that right above this set mode, and we'll call it wait for retrace. And it will be very simple. First of all, we will read that thing and combine it with the vertical retrace bit. And we will do that as long as this thing is 1, because maybe we are currently in a retrace and we don't know how long it's lasting. So that's why we skip the first retrace, and maybe we are not in a retrace, then this will just skip. And then we'll do the exact opposite. We will say, well, this bit is not set and we're not in a retrace. We will wait. And then we have the guarantee that whenever we come out of this while loop, we are safe for 1.25 milliseconds. Right? This should compile, but we need to still call it. So one more try. This is without. And now let's call it, and we will call it whenever we start our next draw loop. Basically right here, right at the top. Wait for retrace. We do everything, the whole handling we will do inside of that. And look at that, the flicker is gone. We are now drawing inside the vertical retrace. One thing you have to make sure is that your draw routine is really that fast. There are ways to work around that, but we will cover that in later seasons, because it will get pretty complicated. We're already so much over time. I think this will be enough for today. The code is up on GitHub again. You can walk through it, but you learned how to copy stuff from the VGA to memory and the other way around, how to draw a rectangle, and well, I didn't change the color of this thing, but you know how to do that in the set palette function, so I will leave it up as a homework. It's already in the GitHub version, it's in there. And yeah, now you know how to do that, we can actually move this thing. Next time we'll try to actually make a game out of this, add some extra action, try to keep the scores, and you can probably already guess what this game will be. But until then, please share, like, and most important of all, subscribe. Hope you are enjoying this and have a nice evening.